Welcome to our Waldner Labcafé online. Thanks a lot that so many people are interested in this digital topic. My name is Alexander Biller, and I'm looking forward to share a lot of inspiration with you. Our topic today, Smart Labs, start your digital transformation. Laboratories are not fit for the future at the moment. Scientists are hampered by aging, rigid, and disconnected lab environments. But how can we transform scientific laboratories into the future? Together, we will learn about how digitally enabled laboratories that leverage a modern data architecture and intelligent technologies such as artificial intelligence, advanced analytics, and extended reality is required to scale, accelerate, and improve the efficiency of lab operations. And we have fantastic speaker today, the digital superheroes from the worldwide operating Accenture Scientific Informatics Services. They will share a lot of insights and know-how from their global projects. Impulse number one is about why digital laboratories are important for the future. With Jeremy Ward, he's principal director, leader in Accenture's practice in Europe, with over 16 years experience in scientific informatics, based in Basel, Switzerland, and leading global client engagement and transformation. Jeremy specializes in working with organizations to transform their R&D, QA, QC, digital and data management practices via risk management, process optimization, and the implementation of innovative technologies. So, Jeremy, it's a pleasure that you're on board. Impulse number two is focusing on the question, what is a digitally enabled lab and what are the digital trends in laboratory organizations? With Donna Keelan, she's senior manager and leader in Accenture's practice in Europe, currently based in Dublin, Ireland, with over 25 years of experience in laboratory informatics and business transformation. Donna specializes in large-scale transformation programs across R&D and QC, working primarily with consumer goods, chemicals, and resource clients to improve processes and deploy innovative solutions to improve quality and decrease time to market. Impulse number three is about how can we accelerate and use the digital transformation to become better with Mark Fish. Mark is a managing director in Accenture's business. Mark has over 20 years of experience in various leadership roles, delivering innovative solutions to the pharmaceutical sector, and is a passionate about drug discovery and development, translation, research and precision medicine, digital transformation, agile software development, and analytic quality, control automation, and a lot more. So at the end, we have a Q&A session. So if you have questions, please write it in the chat. So I would say, let's start and let's learn from the digital pros. Take a good cup of coffee and be inspired. So Jeremy, it's your turn.
Yeah, thank you, Alex. I appreciate you having us here. And hello, everyone that joined. As Alex said, I'll be talking about the why digital laboratories are important for the future, but also for the now. I think they're already becoming highly important. As we look at where we are today, I mean, we are living in exceptional times. We have a huge amount of pressure on us, and the business of science is feeling that pressure. We see kind of four trends as to what's highlighting the urgency for us to accelerate this digital transformation of product development. And we see these amongst, the last 2 years or 3 years of a COVID pandemic, and then now as we move into pressures on energy, and every company is feeling the pressures from all angles. But in our particular sector, healthcare is requiring those cost-effective treatments. Again, people are seeing the energy crisis, they're feeling this, and they're requiring those reduction of the cost of drug development from where it's at billions today to millions, and hopefully in the future. The complexity of the development and manufacturing is continuing to increase. New science needs to deliver healthcare outcomes faster. As I mentioned, the pandemic has been a huge emphasis around shortening that development cycle from decades to years. And we've shown it can be done in the instance. Now we need to continue to push that forward. And then lastly, in order to just survive COVID times that we had, digital transformation needs to be there to increase our digital talent and is key in order to keep our business resilient. But I think, as all of us know, laboratories and lab IT today can't support this new business expectations. We've got a lot of technical debt that we're burdened with. Transformational thinking is required, not only for the fundamental, but some of the aspirational goals. We still need to make sure we're doing the fundamentals and the basics brilliantly in order to hit this goal. But again, laboratory has a lot of headwinds, and the industry is pushing back on us a little bit. New science isn't easy, it's complex. But based on the urgency that we have, we need to transform. And there's multiple headwinds here that we'll talk about. If we look on the right side, we start talking about the products. As I mentioned, the products are becoming more and increasingly complex. They require more data. We get more data outputs, and we require more analytics on that data to understand where the problems may or may not be. Amongst the increase in complexity, drugs are getting increasingly more niche. Cell and gene therapy, patient-specific therapies. We got low volume, but high mix batches in production. So it becomes harder for us to not only manufacture, but make sure we're testing. We're not dealing with a lot of huge batches. Continuing to increase to get drugs to market, faster approvals are getting pushed as well. So that puts process development and manufacturing on a critical path. And we need to make sure we have the speed and agility to handle those. Integration is key, making sure that we're aligned, developing the different aspects to make sure that we're aligned across the networks, feeding data across. And today it's just not happening. If we move over to the left side, we talk about the business. Again, industrial revolution is upon us. Manufacturing is changing. Ultimately, they'll change the way we get work done, how patients are experiencing our products or our services that we're providing them. The new models that are coming out from a business perspective revolve a lot around patient centricity, right? Patient-specific therapies, which again is a big change for the lab. And then if we look at the ultimate push around new models, complex drugs, trying to push faster, cost is a huge focus. Competition and the challenges in the healthcare environment are really pushing us to focus on costs and make sure we have the appropriate business outcomes. So maybe this will give you a little reminder, but what we feel a current lab looks like today. And I'll walk around the picture a little bit. As you can see, it's pretty dark. There's not a whole lot of light in the labs today. As you can even see further up in the top right, it looks like we're in the basement, because a lot of times that's the way the laboratory feels, down and in the basement. As we move through the picture, we'll talk about this top left up here. Teams are coming in, they're trying to prioritize the incoming work. Those priorities are typically done on a whiteboard, and they're changing so often that we can't keep up with what the new highest priority is. But we put a lot of pressure on those schedulers to make sure that we have work in the schedule for our people and that we're hitting our SLA timelines. As we move down into the middle, you can see on one half of the desk, you got multiple people doing lots and lots of paperwork. You got one person not real sure what the priorities are, but worried because they know they have to make an SLA, but they're not sure what they're supposed to work on next. And then on the other side of the desk, a little bit of boredom. People not sure exactly what they're supposed to be doing today and just not motivated, not driven. As we move down a little farther into maybe one of the light spots, all that paperwork and shift has gone to a person who's just buried, trying to swim his way out to the top. But based on all the paperwork that's done, we have to double check and triple check, and it just becomes a whole bunch of work to go through that paper. We move a little to the right, and we see scientists looking for samples. It almost seems like the samples are running the show. We don't know where they are. They're not where they're supposed to be. And when I go to find them, oftentimes maybe a label has fallen off and I don't even know what this sample is. Right? It becomes difficult to understand the process. We move up to the middle of the picture and we see the collaboration between manufacturing, quality control, and R&D, or maybe lack of collaboration. The walls are built up and we're just tossing things over. Manufacturing's constantly tossing new samples over, sometimes aren't even sure what the sample is, and quality control is trying to catch it amongst the other 15 things they're worried about. And then on the right side, you have R&D, who's tossing new methods and new SOPs over the wall constantly, which again, quality control is trying to understand, get training on, understand how to tech transfer new things. So multiple priorities, not all aligned. As we move down to the bottom right, I think we've all maybe experienced this in the lab, that I've got multiple stacks of paperwork and that paperwork isn't digital, but I need to get it into a digital tool because people are always wanting to see my data, whether it's in Excel or whether it's in a separate database. I'm constantly transcribing things from one computer system to another computer system, typically from paper. So I'm on this constant swivel chair back and forth to really try to get the pieces and parts in place where they need to be. If we move up slightly to the guy whose hair's on fire because his bosses are always asking for numbers. I want to see trend reports. I want to see where we are. What's our typical SLAs? I need the reports out. I need the report out to go here. But he's dealing with paper typically, or Excel spreadsheets. He's trying to combine data sets, and it's just to try to get a trend report. And it becomes difficult to find a piece in the day, and typically you need about 4 or 5 arms in order to handle and pull all the right pieces together. Move up a little bit to the top around somebody typically investigating a deviation. But the investigation, where it should be focused on the problems and looking at the data sets that are already there, is typically becoming an investigation just to find out where is the data. So looking through mountains and mountains of boxes, probably some offsite storage, hopefully that it's labeled correctly. But in the end, just working through paperwork, trying to really just find the data to really start the investigation. It becomes a timely issue. And then the top part, which is probably one of the most important parts, is typically there's a revolving door of people and talent. The unfortunate part is we're seeing our experienced talent leave because they're tired of the paperwork. They're tired of the manual work. They have an iPhone today, right? They're dealing with digital in their world. They got a smart house, they got a smart light. Things turn off for them, but they come in the lab and they take that digital persona coat off and they put on their lab coat and they grab their lab notebook and their pencil and they move into the lab. And then you have newcomers coming in from college who get a stack of SOPs and paperwork, booklets dropped on their desk. And that's what they're supposed to learn from, which is a far cry from what they're learning in college today, that even in middle school, high school, they're getting an iPad or a laptop, and that's what they're learning on. So the incoming experience isn't great. So we got lots to do in the lab, lots of things that we need to work on to make it a better place and to get out of the future. But a lot of why it's important for now and in the future to try to digitize certain aspects of the lab. Now we've done some research on internal side. We actually interviewed around 118 leaders in the lab industry across R&D, across pharma, across development, across QC. And here's some of the results we see. Clearly, transformation has already begun, but people are having a real problem scaling that transformation. Those that have had success, the digitized lab reports significant value, right? 73% faster access to data, 57% less manual efforts, and 51% increase in collaboration, which is fantastic numbers based on where we are today. But what we're seeing the trends is 91% of the labs are accelerating action towards digital, right? Companies are seeing this as an area they need to fund. But 77% of labs haven't yet started or are stuck in the early piloting phases, trying to get to that transformation. We talk a lot about pilots and pilot purgatory. It's oftentimes easy to get stuck in a piloting phase. We just move from one pilot to another pilot, and we're not getting the results we're seeing, and we're not, maybe we're failing fast and we move to the next one. Maybe we get a success, but scaling that success is very tough. So we really got to push through that piloting phase, push into scalability, because that's when you see the main results of this. It's hugely important. The lab transformation is often seen as a costly and complex beast. Oftentimes we hear it's just the lab is a black box for me. I'm not real sure what happens in there. Samples go in, information comes out eventually. But to realize that end-to-end value, we got to make a fundamental difference. We got to scale the approach across the end-to-end network. Okay.
So thanks a lot, Jeremy. And for this current view, for this cool picture you showed us, the need for change in laboratories. I have the first question to you. Do you think the COVID pandemic has impacted the pace of digital transformation in laboratories?
Yes, and thanks for the question, Alex. Hugely impacted. As you think about the labs today, oftentimes you have to be in the lab to access information or the instruments. Sometimes people don't have access to the data outside the lab. And when COVID came in and the restrictions on the number of people that were allowed to be in a particular place at one time, or even in the workplace at one time, that really brought the need for people to think about, well, if everything has to be done on paper in the lab, how are we going to meet our government or company restrictions, knowing that we still need to hit our numbers, we still need to push out drugs, we still need to get things through the lab, and start to think about maybe if we digitize a few of these pieces, things can be done from home. You can view your data from home and do more information from outside the lab, and we can meet those regulations. In addition to that, I think the push for driving the digitization and driving the sign off of new drugs much faster requires digital. I think a lot of the agencies today are like, I don't want to see the paperwork. I want to see what your digital system has today. It's hugely important.
Okay, thanks a lot, Jeremy. So I would say we go to the next impulse from Donna. Donna, it's your part.
Thanks, Alex. Hi, everyone. So now we've talked about the why, talk about the what. So what is a digital lab? What does it mean to be digitally enabled, and what are we seeing in the clients that we have today? So today's lab needs to be fit for purpose. It needs to be enabled in a way that drives innovation and agility at scale. So what does that mean? It means moving away from paper towards processes that are digital, that are automated, which allows scientists to leverage technology in a way that's both optimized and orchestrated. And it behaves like an extension of them and the work that they do, as opposed to them feeling like shadow IT in their own lab. It means moving from analog systems to systems that are digitally enabled, customizable systems that are decoupled. They're scalable, adaptable, they drive efficiency and allow for continuous improvement in the lab. It means moving from silos that prevent real-time visibility into key information and limit cross-collaboration. It means moving to control towers that provide real-time visibility into metrics, KPIs, and the ability to leverage historical data when making decisions. It means moving from siloed and difficult to access data to boundaryless data, with the ability to generate the insights that enables performance, allowing for the growth and innovation needed to succeed in a highly competitive market. So Jeremy showed us what the lab currently looks like. What I'd like to show you is what the lab could look like. So if we imagine, in the contrast of what Jeremy showed, this is what future could be. The vision of the future is enabled by innovation, digital innovation, and it promotes collaboration regardless of the stage. So if we look at the center, we have R&D, QC, and manufacturing all collaborating seamlessly, right? There are no barriers between them. Samples know where they need to go. We have people coming in that are happy to come in. We have Wi-Fi everywhere, so we can enable the Internet of Things across the lab. When we're doing planning, the previous version of the lab, we saw whiteboards to use to prioritize work, and nobody knew what they were doing. Here, clearly, we have prioritization. We're looking at digital dashboards that help tell us and predict trends, right? So we know how to be proactive as opposed to reactive. All of this leads to an increase in a workforce satisfaction and an ability to attract the best and the brightest, which is really important in today's market. And, we see here, we have our nice, happy Zen researcher. So this level of transformation is facilitated by a number of technology accelerators. These not only accelerate, but in some cases, they're foundational to the transformation itself. So if we start with comprehensive data strategy, and you'll see when Mark discusses the how, this is foundational. Whether you're looking at Alcoa or fair data principles, the key is to ensure the data is created with integrity, that it's unlocked so the value can be realized from the very beginning. If we think about the Internet of Lab things, we want to create a network of things like smart instruments, smart samples, smart storage to create seamless connections and reduce the need for manual interactions. Imagine having a cobot that pre-screens your microplates to eliminate obvious negative results, allowing time to be focused where it really adds the most value. If we think about the scientist and connecting the scientists, creating a world where they are truly connected and unencumbered by the limitations of being tethered to a system. Imagine using AR for guided method execution, ensuring step-by-step execution of the latest SOP, coupled with direct data capture. No more manual entry, no more paper printing of SOPs, and all of this ensuring right first-time quality. We then move to leveraging of applied intelligence, using AI machine learning to drive new discoveries and insights based on historical data. Imagine the ability to predict the likelihood of an experiment success based on previous outcomes, to limit the need for physical experiments, thereby decreasing the time to market of new products and improving environmental sustainability. This is done through the reduction of materials and waste from not having to execute physical experiments. And finally, we'll talk about platform architectures, which, much like data strategy, is not only an accelerator, but it's also a foundational part of the transformation. So in this case, imagine a world where you're no longer hamstrung by it taking years to do an implementation of a capability that you so desperately need, or being bound to a single vendor, but rather you're able to deploy fit-for-purpose capabilities faster with improved performance and in many cases, reduce cost. So while the technology accelerators are important, to be successful, the culture and the people need to be at the forefront of the transformation journey. If we think about the current lab slide that Jeremy showed, it very much felt like a bit of the Stone Age. Especially when you think about it in the context of the labs, or the lives that we lead outside the lab. In the outside world, you have voice-activated digital assistants that do everything from play your music to create your shopping lists. You leverage QR codes to wirelessly log into streaming services without having to type multiple passwords. Digital transformation enables the integration of systems, prioritization of work, reduction, and in some cases, the elimination of non-value-added tasks, allowing more time for innovation and collaboration. This creates an environment that also allows you, as I said before, to attract and retain top talent to support your business and create value across your product lifecycle. But how do we connect the business value with the digital transformation? We see this happening across 4 pillars. First, we look at operational efficiency. So here, the lab environment of the future creates a place that functions at optimum capacity and can more readily adapt to new products or volatility in the workload. So regardless of the number of labs coming through number of samples coming through the lab, you have systems in place that can predict and be adaptive rather than reactive. When we look at collaboration and connectivity, here we're promoting greater connectivity and creating a lab without borders. We're removing silos and enabling collaboration, which in turn allows scientists to focus on the science. When we look at data, we're trying to ensure access to trustworthy data across the labs. Innovation becomes more effective and data can be more easily accessed to speed the process from discovery through product release. Data can also be leveraged to rapidly develop new ideas and improve existing products through the use of AI rather than running large numbers of physical experiments. Working this way not only increases your speed to market, it allows the company to be more agile, and it helps to achieve sustainability goals that we're all working to hit. From a human experience standpoint, and I think this to me is one of the biggest business value drivers. I've mentioned it previously, walking into labs today in many cases is like walking back in time. It is a very competitive job market for research and talent, and improving the human experience by bringing the best and that the modern digital world has to offer into the lab creates a much better working experience. It ensures knowledge is retained, and it helps you to attract the best and brightest talent. So now I'd like to show you a couple of examples of where we've implemented this type of digital transformation at clients. All right.
Let's think through how we might improve the human experience, the experience of the scientist, by incorporating automation and robotics in the lab. Imagine, if you will, those repetitive and mundane tasks that take scientists away from their primary missions. As you see here, our scientists have set down a stack of plates that was collected within a sterile fill-finish facility. The cobot you see has then automated that QC micro-testing workflow. By applying artificial intelligence, machine learning, and machine vision, coupled together with cobot technology, this solution has fully automated this high-volume and mundane activity. The cobot collects the plate, presents the plate for image capture, and then there's algorithms running in the background to identify growth and document the results of the collection. Because this repetitive task has been replaced with automation, our scientists are able to get back to the science. We live in a time where technology is all around us, so let's see how we can incorporate that into the lab through the use of virtual reality. VR allows us to immerse the user in a specific experience from wherever they are in the world. When it comes to the lab, this could mean training in a virtual space, modeling compounds in 3D, or even virtual collaboration within an alternate environment. What you see here is called BioVR. BioVR is a virtual reality package that aims to teach the user how to work safely within an aseptic environment. This is but a small example of what we might create to eliminate the need for a trainer, create a repeatable solution, avoid wasting costly and harmful chemicals, and even gather data about training performance and certification. Besides the savings in time, cost, effort, and materials, we're able to train our people in a much more impactful way. VR is engaging for the user and ensures a hands-on experience without touching the lab at all.
And with that, I will turn it over to Mark.
Okay, thanks a lot, Donna. Thanks a lot for sharing this video and exciting examples. I directly have a question for you, Donna. Do you have tips for organizations looking to accelerate laboratory transformation?
Yeah, I think one of the key pieces is that this needs to be a collaboration between IT and the business. That partnership is key. And at its core, the transformation impacts people, processes, and technology. The best technology in the world is not going to help a poor process. So start your journey by understanding how the work is being done. Find the pain points and align on the improvements you want to make, and then look for technology to support those improvements and develop a strong roadmap that gets you where you want to be. It's also important that we involve end users the whole way through the journey. It makes them part of the transformation, and it helps them to feel that they have a vested interest in what's happening, and they're participating, as opposed to them getting to the end and feeling like it was something that was done to them and that they didn't have an input in.
Okay, thanks a lot, Donna. Now I directly hand over to you, Mark.
Thank you, Alex, and thanks for that, Donna. So really enjoying the presentation so far, and I think it's been kind of really interesting. Jeremy's kind of laid out really the why, and hopefully articulated a pressing need to do something different in the lab. And I really enjoyed his description of the pictures going around, some very real problems that hopefully for the audience really resonated, and you're able to connect those to your own scientists and your own laboratories. And Donna's kind of shared some insight into what, and hopefully some of the things that landed there, that there is a continuum of technology that's available to help really transform the life of scientists in the lab, and and drive some of those business outcomes that can make a difference. The operational efficiency, the connectivity and collaboration, that's all important to do good science. That frictionless flow of data to the scientists so that they can make decisions and about the business, about batch release, or when we're ready to file, or even if that new target is viable or not, for example. And also the people being at the center. I think that's a really important message. I'm gonna talk a little bit from rainy Manchester about the how of the journey, and share, I suppose, some of my thinking, our learnings about how to really accelerate from the laboratories of today that Jeremy shared a perspective on, to a digitally enabled laboratory of the future, a lab without borders, or whatever term you choose to use, but a new destination. And just share some of the things that we found from with working with clients that work. So I'll just share my screen. So that question of how, I think there is no single silver bullet. There is no single threaded approach that can deliver your strategy for a lab of the future. You really need to think very holistically, because there's some key challenges that really need to be addressed to move from the current state to where we want to be. And I think some learnings that we've had from working with a lot of clients on this journey, I've shared in this slide. I think it's really important for any journey, actually, that you know where you want to get to. That you have a future state in mind, a North Star or a vision that really aligns importantly with the needs of the business, of what the business needs to be successful. So often we work with clients at the start to really kind of help co-create a vision for the future of what the laboratory, the transformed laboratory, might enable in terms of outcomes. So have a destination in mind for sure. The next one I'll go to is the diagnosis before prescribing. It's kind of interesting if you look at a lot of reasons why digital transformations fail or get stuck in the pilot mode, which our research shows, there are, I think the number is over towards 70% of digital transformation initiatives get stuck in a pilot mode. It is because for a couple of key reasons. One, sometimes these are technology-led, and transformation of the labs isn't about technology. It's not technology for technology's sake. It's about taking the scientist on a journey more than anything. It's about aligning to the needs of the business, and the technology is the enabler. It's not the thing to lead with. So talk to your scientists, walk in their shoes, talk to the business, understand the challenges the business needs. Do the mapping of those journeys. Do really rigorous diagnosis before making any technology decisions. And too often, I think we see IT leading with technology before really the problem statements that are being solved for are really thought through and articulated. And so there's a tremendous amount of value we found in really understanding the business and the scientific needs that need to be accommodated. The third one's a really tough one because it's tough today, really tough, and it's getting tougher. It's going to be talent that determines the pace that you can change and transform your labs. It's not going to be the technology. Having talent is incredibly scarce. The talent that has those essential ingredients that of an understanding of the business, an understanding of the science, and an understanding of technology. Those are the perfect people to be involved in helping you realize your laboratory transformation. And they're hard to find and getting increasingly harder. We see in the industry huge demand for talent with specialist skills in areas like LIMS or chromatography data systems or laboratory notebooks, and there's a sparsity of that talent, and it's getting worse. But it's that kind of talent that will help help you in the journey. So look for it in the business. Look for people in the business who really enjoy the IT. Take some of your scientists on an IT journey and pull in the right partners as well. I think that's important because the talent factor is huge. And last but no means least, I think the picture Jeremy described really showed it well. I think we're putting a fine point on it. Too long the lab has been ignored, and we have piled on technical debt onto our lab IT environments by heavily customizing systems that have really stretched beyond their natural boundaries, and using very bespoke tools, very bespoke skills. I mean, the lab has the long tail, particularly in research. It's very specialized scientific applications that may have a very, very small population of people who can even use them or understand them. There's a huge burden of training for some of these tools, and maintenance and development can become a real challenge. So it needs a new way of thinking, and the business needs to address that technical debt. We need to break out of this thinking that you have laboratory PCs that sit on an isolated network. Laboratory IT needs to be much more commoditized, much more standardized, much more manageable. And I'm going to share a little bit some of the approaches that we found that can help with that journey. But there's one thing I definitely encourage: start to pay back, pay down, break out of the cycle of investing in technical debt. Look for future digital technologies that can take the business on the journey to where it needs to be. Another part of the how, and this to me is, if there's one thing to take away from this presentation, something I found personally very, very useful as a frame of reference to kind of enabling transformation in the lab, is that it's a journey with stages, and the stages overlap, and they are foundational, transformational, and aspirational. I think what we often find, there's a very aspirational vision to maybe automate everything, or use AI to do batch release, or in silico drug discovery to massively accelerate the targets. And those are all good aspirations to have, and real aspirations that can be realized. But the problem is that too often the focus is on the aspiration without thinking through the foundational and the transformational journey that needs to occur first. What we see in nearly all our clients' labs is that, going back to that technical debt, there's a huge amount of foundational work that needs to be done to enable this journey. And a simple way of putting it is, how many of the instruments in the lab are actually connected? Is there a place you can go to review all of your instrument data? Is that data fair? Can you get to it? Can you get to it to even start to make decisions? Until you resolve some of the foundational challenges of legacy systems, lack of connectivity, lack of collaboration, poor understanding of the business drivers we're trying to achieve, it's very hard to pivot to that central stage of becoming data-driven, having the data fair, having Alcoa data that you can trust, as Donna put it, trustworthy access to good data that you can find and you can use to actually build on, is where that center spot, the transformation, that's where the transformation really starts. When you have mastered your data, you can pivot to data-driven ways of working. You've started to execute on a robust data strategy. So again, another thing we'd really recommend for the lab, as well as having your digital strategy, think about the data, think about how it flows, the value of it. Is it trustworthy? Is it managed? Have you got a technology platform to help you with the data as well? And to have a good technology strategy. And when you start to pay back some technical debt, look at the foundational connectivity, have the right strategy and tooling and people to help steward and manage the data, then that unlocks the ability to become AI-driven, automated, start to get the insight on demand, or even automatically from the data that's in the lab. So it's a journey of 3 parts, but consider the activity that needs to be done in your environment in all of the three areas. Don't over-index or over-focus on one or the other, and then you can rise up that maturity curve. But it needs all three fronts to be considered. One thing increasingly we found that really helps with this journey is to take a more holistic platform thinking to the way you approach digital transformation in the laboratory and transformation in the laboratory in general. We know that our labs are full of very specialized equipment and specialized applications that support that equipment by the nature of the science that we do that's complex, challenging, or constantly evolving. And that's the beauty of science. It's always innovating. But we need to break the IT cycle of bespoke and legacy applications in a way that enables us to adopt more platform-based thinking, more things like cloud and SaaS technologies. But the good news is this isn't a radical tear it up approach. We saw on the first slide some data that a lot of people would actually like to start fresh with their IT platforms. That's not what we recommend. Actually, you have the operational backbone systems in your IT organization that are running your business and may have decades of investment in things like your ERP systems, your manufacturing execution systems, your laboratory information management systems, your ELNs. These systems have decades of knowledge and value and are fundamentally running your business, and they're hard to change. They are absolutely not the place to play around in digital. Using them as a digital playground for new digital initiatives is not a good recipe. What we would recommend is taking a decoupled approach, looking at newer technology architectures that can enable a connectivity to those operational backbone systems and allow them to be augmented with new digital capabilities through interfacing, through the liberation of data, through the right data models and data and interface models, that things like microservices, things like thinking about data fabrics, thinking about connectivity, thinking about orchestration, build that integration layer that then enables you to look at new capabilities in the cloud, fundamentally newer cloud-based technologies. Maybe try a new SaaS technology that integrates into your ELN or LIMS. There's some fantastic AI tools out there. There's some fantastic connectivity tools out there. There's brilliant tools to enable you to execute SOPs, for example. Have a look at how they can be integrated with these newer cloud and SaaS technologies into your legacy systems. And the beauty of using technologies like new cloud services from Amazon, great example with AWS, we find there's a lot more experts available who can help you then and implement those new capabilities more rapidly, working hand in hand with the business. You're no longer looking for that unicorn engineer who is in the right place with the right limb skills and an understanding of your business. Instead, you're looking at a much bigger pool of maybe cloud engineers or web service engineers or Amazon, Google, Azure engineers who can then help you engineer new capabilities in a new cloud platform. And that's fundamentally the platform concept that we're working with a number of clients on. The last part of it, which is super interesting, is that we've found actually by using things like low-code tools, and there's many good examples out there, you're able to actually then, if you have this infrastructure, you can create the new human experience, even enabling your scientists to do it themselves, building, say, digital versions of specific forms for specific reasons in low-code tools like Appian, Mendix, and there's a variety of them out, or Pega. But if you take this platform approach to digital transformation, you can progressively move new capabilities to the cloud, keep your operational backbone that's running your business stable, constrained, doing what it does well, but not trying to force new digital workload into that operational backbone, where you're using the new fit-for-purpose modern technologies that, to be honest, what we found, you can develop things 10 times faster in these newer technologies than trying to do them in legacy technologies. We've got some fantastic data on how fast it is to digitize, for example, methods using new approaches, older approaches, and it can be 10 times faster. So going back to the journey, I think we talked about some platform, we talked about technical debt, the stages of the journey, some real examples of, and I'm not going to read through this slide in detail. It just shows you some ideas maybe that you can look at and what aligns with different stages from where you are today, probably paper-based, probably like that, aspects of that diagram that Jeremy talked through, to the world that Donna talked about, the lab of the future, and some of the steps in the journey, maybe more concrete, maybe like roadmap items you could think of that might help you in that journey. And that's what we tend to recommend as, think about where you want to end up with your labs to meet your business and scientists' need, and then come up with manageable, pragmatic projects that can be scaled quickly to help you on that journey. And this slide has a number of those sort of typical projects, many of which we obviously help our clients around, looking at great things like transformational augmented reality today is really finding its place in areas like technology transfer, method execution. At Accenture, we're doing a lot of work on the metaverse, which is about a continuum of these types of technologies. Donna had a lovely example there of VR-based training, which can deliver very real value for onboarding new members of staff, for maybe visiting a lab before you've ever visited there, is talking to colleagues who work in the lab, in that environment. Fantastic, easy wins for collaboration, connectivity, and changing the human experience. And going back, I suppose that human experience, that people part of it is very, very important to your transformation journey. Getting the business bought in. So the business are pushing. It's not IT bringing something that the business doesn't necessarily understand. Think about the organizational aspect of it. Bring the business on the journey so they want and understand the value of the digitally transformed. And finally, my last slide really is what we have found when clients do look at transforming the lab and realize these steps, and it's a journey in many stages, and it's progressive, and it's not a big bang. It's about incrementally looking at new capabilities to transform the lab and building on top of your existing solutions, that you can deliver tremendous value. And have the value in mind when you start the journey. Think about what will make a difference to your business and align your digital and lab transformation journey with the business value. I mean, in things like QC manufacturing, we all know that there's huge pressure to release batches to market quicker. In COVID times, things like vaccines, this was something that had to be solved for. And so we've shown we can do these types of things as well. And we've seen it in the more traditional areas as well, that by enabling that frictionless flow of data, you can make decisions quicker. It requires a holistic view, perhaps being beyond the laboratory, looking at electronic batch records or supply chain data, but you can bring all those things together, get the data to flow, make decisions much quicker, get to that one button batch release, right time batch release, intelligent batch release. Lab efficiency, I mean, just moving away from paper. We've done a lot of research with a lot of clients, looking at, walking in the scientist's shoes, understanding where they spend their time. And it is anywhere between 40 and 60% of the scientist's time is spent not doing science. What it's spent is just wrangling with data, getting data into Excel, formatting it, reporting it out, getting it in the right shape. 40 to 60% lost productivity just wrangling with data. One project I was involved with, one of the success factors was stop doing work in Excel. I think that's not a bad one. The other one, interesting, was get rid of all the USB drives, which is another good one to have. I mean, too often we see connectivity being solved with brute force and very insecure ways like USB drives, for example. That unlocks a lot of extra capacity potentially. Another thing we do is things like looking at lean, having a look at standardizing work, thinking about standardizing of work from a digital way of thinking. So you can enable digital planning, digital scheduling. Obviously, sustainability. Some of the work optimizing a process so that it is more labor and material efficient can unlock tremendous value. It's some great work. We've been looking at clients looking at things like bioreactor yields. And we've done some work with, for example, NIBRT, looking at models of digital twins of things like CHO cells to optimize yield, push the biologics yield up by a number of percent. All of a sudden, that's a huge sustainability and efficiency gain. Again, just unlocking data that's available in the lab or in the plant, and then looking at some of these new tools to develop predictive models. And other clients working on how you can predict formulations, sensory attributes from data to move some of your lab testing, your wet lab testing, maybe into dry lab in silico models, so that it can be done quicker. And that's definitely another trend we see, the shift of work from the wet lab continuum to a data-driven, data-centric AI world of dry labs. And I think in the future, that's something you'll see more of, scientists spending their time between wet labs and dry labs. So I'm very excited, as you can probably tell, about the potential for the change in the laboratory. I do think we're at a place where the inertia for change is just compelling, and the leaders in the industries are embracing this change. There is no reason not to transform the labs, and we're at an interesting time that the technology has reached a state of readiness and commoditization that it's not the huge lift necessarily that it might have been even 4 or 5 years ago. So I think I'm hopeful that we'll see many of our laboratories truly transformed in the coming months, years, hopefully not decades. But I think now is the time for change, for sure. Back to you, Alex.
So thanks a lot, Mark. Thanks a lot for your holistic view to this topic and showing some numbers from your practical world work worldwide. Do you have advice for organizations when it comes to starting a laboratory transformation journey?
Yeah, great question. I think there's a few, and I've touched on them a few times through the talk, but I think it's worth reiterating. I think creating that clear picture of where you want to be is a great place to start. That can really help engage the business, start that change journey, because a transformation is about change. So it's important that everybody buys into it. And when you're starting any journey, you need, is it good to know where you want to get to? So I'd start with that. I think about the tools and the work that's already been done. Put together your bus for the journey in the right way. Get the right people involved in the journey, because that's super important. Think about the technology providers, the business stakeholders, and get the right talent. I think often, the business case needs really good thought. I think that's part of it. Justify adequate involvement of business resources in particular. Too often the business resources aren't adequately involved, or that amount of work is underestimated. So I very much recommend get the right people on the journey, invest in that, bring some outside in perspectives as well, obviously helps with that. And finally, I think that really do think about that, doing the basics beautifully. Start with that, pay down some of that technical debt, connect the systems in the lab, connect the instruments, just pay back some of that technical, get the lab doing the basics beautifully, because that enables the transformation and the aspirational journey. So I think those are 3 things. I think the people, the platform, the technical debt, and have a good endpoint in mind that you can get people excited about.
Okay. Thanks, Mark. I look to the chat and there's a question from Dennis Fink. It sounds like moving towards a digital lab resembles a huge mountain that needs to be climbed. Is moving from paper-based to electronic lab notebooks the best, easiest first step? On what factors should one choose between?
That's a great question. And, it does go to, I suppose, what I talked about is to take a capability by capability centric view of things. Think about, you don't have to take the leap all in one go. A lot of organizations do. I will say that with a lot of companies, for example, are looking at what is our right lab notebook strategy, and we help with that. And there's some really great new technology out there that is truly SaaS enabled, next gen web enabled, and some great advances in all the different areas of lab IT. But you don't have to take a big bang approach. I think that's when we talk about digital decoupling, that you can take a more measured approach, capability by capability, but do that in a way that you're paying back the technical debt. Invest in the right speed boats would be one way of looking at it. Things that can impact the business quickly and can be quickly scaled. That can be just simple things around maybe connectivity, maybe around lab scheduling, maybe around insight or use of data, verification of data. Maybe it's just simple as networking. I mean, that's a really good one to tackle. And when you take these small steps, they can all build momentum into the journey. And as you progress, the bigger changes get easier. But definitely do the basics, progress there.
Okay, yeah. Thanks. So I will bring Jeremy to the board again. And do you want to add something, Jeremy?
Yeah. I think I see the second half of the question around on what factors should we choose between the large number of ELNs or technology that's out there. So I echo Mark's point of, how do you eat an elephant? One bite at a time, right? So you got to take those small steps. Where to start, how to start. I think we showed a few things on the presentation. How to figure out what the right technology that you need is. I mean, obviously you can find a good partner, right? A partner that knows the right technologies that are out there and help guide you to where you should start, how to get off on your journey, what the journey should look like. But back to Mark's point about, let's make sure that this is business driven, really understand what the business needs, understand that business process. And if you're going to go into something that's requiring a technology like an ELN, create those business cases that you can give to a technology company that can play back to you how that technology would work within your business, so that you see firsthand it working within the cases that you already have that's going to solve your business problems. So I think that's a key piece around the factors of how do you choose the right technology, is making sure you're making it business driven, business case driven.
Okay, another question to you, Jeremy. What are the barriers to adopting new technologies in the laboratory?
I think Mark hit on one of them is technical debt, right? Sometimes we're investing in the technical debt that's there, and making sure that we get out of the silo or the continued thinking that, well, we have a LIMS, we just need to replace the LIMS, or we have a ELN, we just need to replace or upgrade that ELN, and start thinking more around. That's kind of an IT focused thinking. Again, making sure it's a business and IT driven initiative. What is the business having the most issues with? What does our future need to look like? And then some barrier is the change. I mean, you need to make sure, back to taking it as a stepwise approach, people can only handle so much change. So making sure that you're bringing and thinking about that organizational change management aspect, finding good change agents. Because oftentimes, we talk about technology is not the solution, it's just the enabler. And one of the biggest barriers we see is people in the labs or users that are rejecting the technology because it's not solving the problem. We just implemented a piece of technology that we didn't necessarily look at the business. So focus on that business first, understand what those are, make sure you're bringing the business along on the journey, because making sure that change journey is well thought out and covered is a huge barrier to overcome.
Okay, thanks. So Donna, come to the table. I have a question for you. Can you provide some outcomes and examples of progress in terms of digital technology delivering value to the organization?
Yeah, so the two videos that I showed are good examples of where we've done that, right? So we've used BioVR to help implement training, the cobot, but it doesn't have to be necessarily something really big. Like Mark and Jeremy have been saying, baby steps get you there just as well. It could be creating a data lake to capture all of your instrument data so that you have access to it, and then you can do analytics and dashboards based on that data. It could be, you can go into a platform approach, but it could be something as simple as using RPA to ingest SOPs, so that when you're building master data for a LIMS implementation, you know that the data is accurate and consistent. You can do it more quickly than you can if you had somebody actually manually building. For those of us that have done LIMS implementations, the long pole in the tent tends to be the master data creation. So this is a way to speed that up. And all of these little tiny things together make big changes and fundamental shifts in how you work. And I think the value that brings is that, we've talked about it, it's speed to market, it's innovation, it's improved collaboration, and it's helping people to feel good about what they're doing and the way that they're working every day.
Okay, another question to you, Donna. In your experience, where does digital transformation in the laboratory deliver most value for an organization?
I think for me, part of it depends on where they're starting. So the question that we had talked about, going from paper to ELN. I mean, if I look at that case, making that shift right there, you're going to get significant improvements in data quality, in right first time. I mean, if you're digitizing the way that the data is collected and you're creating that seamlessly so that there's no handoff, or there's no thumb drive, there's no file tray, things like that is going to improve data tremendously. I mean, as you get farther down the digital journey, the value that it brings shifts slightly, right? So it becomes, the more digitized your environment, the more that you're doing, for example, a platform approach, then you really get into speed to market, moving from wet labs to dry labs. Those are things that are really important. If we think about, I think one of the questions that Jeremy had was about how COVID has changed the digitization path. It became very apparent that we needed to speed the process of getting vaccines released. All of that creates, that speed to market, and the need to do that is a huge driver, and it is value because it makes companies, helps them stay competitive in a very, very quick shifting market.
Okay, thanks a lot, Donna. So the last two questions goes to Mark. Mark, what do you think? What are the biggest challenges clients face in terms of transforming laboratory operations?
Yeah, so it is contextual, obviously, to the client's own circumstance. So there is no one answer to necessarily to that question. But I think, even in the different areas of what I'd call the value chain, different parts of the business, the driver may be different, and so the challenges may be different. But I think if I was to sum it up, I think we want one simple answer. I think the biggest challenge is people, not the technology. I think the technology is ready, but there are lots of people challenges that need more focus. I mean, Jeremy and Donna both talked about that transformation is fundamentally about change. So you need to take people on a journey, and good IT projects are measured by how easily they're adopted and how little they disrupt people's work. So, that's really the key, is I think that the people issue, in one way, not minimizing the impacts on the people, in another way, maximizing the outcome for the people so that they get back to doing scientists. So I think if I was to sum it up, it is the people issue. Get your scientists, get your researchers doing research rather than fighting with paper or fighting with data or hunting for data. Overcome those challenges. Get the right people to help. You need the talent gap, talent sparsity I talked about. But I think fundamentally, that's the biggest challenge, right? Talent, retaining talent, and then taking that talent on a journey so that they're able to do their work better. So yeah, I think if I'm to go for one answer, it'd be the people.
Okay, thanks. And you talked about fair data in your impulse, Mark. The fair data concept is clearly important for laboratories. Why is it so hard to make laboratory data fair?
Yeah, I don't want to say it again, but I'm going to say it again because there's a lot of technical debt. Fundamentally, if you look at a lot of traditional LIMS projects, the one thing that gets put on, keeps getting pushed back, is the connectivity to instruments. And so it's the thing that everybody tends to put off or push to the back. And you can see that in ELN and LIMS implementation, because there's a lot of complexity down there. There's lots of different types and brands of instruments, and it's difficult, and people have to maybe be in the lab to do it. But I think we have to take that one head on, because fair data, you have to be able to find and access the data, and too much of our laboratory data just isn't searchable. You can't search it. It isn't in one place. So having a good data strategy, that's what's important for fair data. Solve the connectivity problem. That's what's the key to it, and make sure people can find what they need. And then once you've got that data together, you can use it in new ways. You can get the insight, get the decisions from the data. So I think, fundamentally, it's that foundation of managing your data with a good data strategy, well, connecting everything together so the data can flow to one place so it can be used.
Thanks a lot, Mark. And thanks a lot to you three and for your time, Donna, Jeremy, and Mark. It was a pleasure, and you showed much insights from your practical work you do every day worldwide. So this was the 10th Waldner Labcafé Online and the first after our summer break. I hope you learned a lot from the Accenture team. And if you have questions or other things, please directly contact Jeremy, Mark, or Donna, or also us. We can give you the information, the contact informations. And if your colleague missed this cool live event, we have recorded this live event. We will bring it to our website in 1 or 2 weeks. So we will also promote that on LinkedIn. And all our Waldner Academy events we have on our website. So other topics like automation labs, like well-being labs, and so on, you find that on our website. Our next Labcafé will start on the 2nd of November in 1 month, and we will talk about lab facilities with BIM, manage complexity simply. So it's a facility topic, and we have 3 speakers. We have the expert perspective with Thomas Geisler from Formitas. We have the operator perspective from Kian Yasti from BASF. And we have the planner perspective to this topic with Annika Schmitz from Carpus & Partner. So register on the website. Many thanks for joining us, and have a nice day. Thank you.
Thank you, Alex. Thank you,
Thank you.
everyone.
Bye-bye.
Bye.
Bye.